Hello everyone. Today we're doing the second activity in the Variables chapter of Learn to Code 2. The chapter Variables, this activity is Bump Up the Value. So this is our second activity and it's a challenge, and our goal is to assign a new value to gem counter. Gem counter is a variable for every gem we collect. Okay, so looking at this puzzle here, there are 5 gems, all we can collect as we walk forward going down the stairs. Okay, I think we're going to do this puzzle 3 different ways, each time getting a little more what I would call elegant in our solution. Okay, so we'll start with a fairly simple solution. It'll get the job done, but then we'll move to a more generalized function, and then finally the last one will be the most generalized, and it will work for any set of stairs of any length, and we'll always collect all the gems until we're done. So just remember from last time that this idea of a variable, we think of it as a box or a container where we can store a value. And in this case, that box or container, it's going to have a name, and all variables have a name. And the name here is called gem counter. And gem counter represents the number of gems that the character has at any point in the puzzle. So our goal is that after any time we collect a gem, right after that we want to change the value of gem counter to reflect the new status of the character, or however many gems he currently has. Okay? So since we're starting at the beginning and the character hasn't moved at all, we want to do what's called initialize the variable gem counter to the value 0. So remember, to declare a variable you say var. So here's our keyword var, and here's the name of our variable gem counter, and we assign it at the beginning, or we initialize it, the value 0. So character has 0 gems at the beginning. Now we can add some code here to have him move forward. So we'll say move forward and collect gem, because he'll be on a gem. And at that point we can change the value of gem counter. So gem counter is no longer equal to 0. We'll now set it equal to 1. Okay? So he now has 1 gem, and we can do the same thing then, right? We could maybe copy this, okay, and then go ahead and paste it again. And we're going to want to do this for each stair, right? So we're going to need to do this 5 different times. Now, after he does it the first time and collects the first gem, he's going to move forward, collect the next gem, and then we want our gem counter to be set to 2. And then he'll move forward, collect the third gem, and then we need our gem counter variable to reflect that he now has 3. So we'll change that to 3. Then he'll move forward, collect the 4th gem, and we need to have our variable gem counter reflect that the character now has 4. And finally, we'll move down to the last step, collect the gem, and have our gem counter reflect that he's collected the 5th and final gem by saying gem counter equals 5. Okay. Now, probably a lot of you are looking at this and saying, wow, that's a lot of repeated code, right? So we have repeated 5 times this sequence of move forward, collect gem, and gem counter equals some value. Right? And that's good. You should be recognizing that by now and saying there's probably ways we can simplify it or make it more generalized if we have repeating code. So we'll run this and make sure it's all working fine, but yes, that should bother you a little bit that we have this repeating code, and we'll think about 2 different ways to solve that in a minute, okay, using functions and loops. All right, let's run this code just to be sure it works. So he moves forward, he collects the gem, and he sets gem counter to 1. Moves forward, collects the gem, sets his gem counter variable to 2. Moves forward, collects the gem, sets the gem counter to be 3, then 4, and then finally 5, and we get it done. Okay? And like we said here, that's great and that's fine, and we solve the puzzle. but I think knowing what we know about functions and things, I think we can do a little bit better here. So let's take this idea of move forward, collect gem, and increment the gem counter, and let's put that into maybe a loop, since we do this a whole bunch of times, right? So I'm going to go ahead and select the code here, and let's get rid of all this, most of it anyway. And we'll keep this, and we know that we want to do this sequence of commands, move forward, collect gem, and then reassign our gem counter. We know we want to do it 5 times, right? It's because there are 5 gems. Okay, so that might argue for a for loop, right? We could say for something like I in 1 to 5, we want to do these 3 things. Okay, we want to do these 3 things. Move forward, collect gem, and then set our gem counter to be a value. Now, this is all great, and this will happen, but we definitely don't want to set gem counter to be 1 each time, do we? Because we want gem counter to be 1, then we want gem counter to be 2, then we want gem counter to be 3, and so on. So we do not want gem counter to always be 1. And that's what would happen if we did this, right? So let's run the code, and we'll just see what happens if we do this. At least let's make sure he gets to the bottom. Move forward, collect gem 1, move forward, collect gem 2, move forward, collect gem 3, move forward, collect gem 4, move forward, collect gem 5, and each time he's setting gem counter to be 1 each time. So that's why Byte is sad here. He's not happy because he didn't solve the problem, which the problem said collect 5 gems, but also make sure your gem counter value always represents how many gems he's collected. And he hasn't just collected 1 gem, he's collected 5 gems. So how can we change this in here? Gem counter equals some value so that it starts at 0, then goes to 1, 2, 3, 4, and 5. Well, if you think about it, we talked about this in the past, but this for loop has an interesting syntax in that there's a variable in the for loop, actually. There's this value I. And I, we've said in the past, I has the value of the starting part here of this interval, which is 1. Then the next time through the loop, it's 2, then 3, then 4, then 5. Well, those are actually the numbers we need. We want our gem counter to also be 1, then 2, then 3, then 4, then 5. So we can assign the variable gem counter to have the value I each time. So if I moves from 1, then 2, then 3, then 4, then 5, now gem counter is getting assigned to that value as well. Gem counter will be assigned to 1 the first time through the loop. Second time through the loop, gem counter will be assigned to I, which is 2. The third time, gem counter will be assigned to I, which is 3. The fourth time, gem counter will be set to the value I, which is 4, and the 5th time gem counter will be set to the value I, which happens to be 5 at that time. So that should solve the problem in a nice, easy for loop. Let's go ahead and run that. Okay, he collects 1, so hopefully gem counter is now 1. Now gem counter is 2, because that's what I is. Now gem counter is 3. Now gem counter is 4, because that's what I was. And finally, the last time through the loop, gem counter gets set to I, whose value was 5 at that time. So now the character's happy again. Okay, this is great. That's certainly a step up from what we had before. We got rid of the repeating code, the move forward, the collect gem, and the setting of gem counter, and we move that all into a loop, which is a better way to do that. But there could be even possibly a slightly better way to do this, and that is because I'm thinking this code works wonderfully for a puzzle where Byte has to move forward 5 and collect 5 gems. It's perfectly fine for that. But there may be a puzzle where we don't know how many gems or the character has to collect as he goes. We don't know how many that will be, and we don't know how long the row is. So can we do this a little bit more generalized? So in that case, we might think of doing a while loop that says, as long as we don't have all the gems, then maybe we want to just keep going collecting gems, something like that. Okay, that's one way we could do that. So let's try this, and we'll put this into some of the stuff into a function. But our general idea will be something like while gem counter is less than 5 in this case, we want to do something. Move forward collecting gems if they are there, something like that. Okay? Now, we know that sometimes it's more convenient to put these things into a function, this abstract idea of moving forward collecting gems if they are there. So I'll do that. I'm going to go ahead and say move forward collecting gems. And that's going to be a function. Okay, it's not there yet, so we'll get the red dot that says we have an error where there's no such thing as move forward collecting gems. So we can add that. Okay, so let's add that here. Function move forward collecting gems. Okay, and now we need to say what that does, move forward collecting gems. Well, the first thing is just to move forward. Okay, and the second thing is check if we are on a gem, if is on a gem is true, then we want to collect the gem. Okay, but one more thing. Before we collect the gem, right after we collect the gem, we need to change the representation of how many gems we have, our variable gem counter, right? So gem counter equals a different value. Now, this is where things get a little bit strange. We don't have an I like we did in the for loop that we can set gem counter to. In fact, what we really want to do, and I'll write this in the code here, is we'll say set gem counter to 1 more than it was before, because we just collected a new gem. So whatever the value of gem counter was before, we want to add 1 to it, right? Add 1 to it. Okay? So this is where things are a little bit strange. We can, in computer science, since this equal sign does not mean equals, it means assign the value to this variable. Well, over here on the right-hand side of this expression, we can say, what was in gem counter before? Well, that's just gem counter, because we haven't changed it yet. So whatever was in gem counter before, if we add 1 to it, we have this expression here, which is, say, gem counter plus 1, and we want to assign that back into the variable gem counter. Okay? This is called incrementing a value, or incrementing a variable. If we have a variable gem counter, we can add 1 to it by taking its current value, adding 1 to it, and then reassigning that new value that is 1 more than the old one to the original gem counter. So at the beginning here, when gem counter is 0, what's going to happen here is when we get down to this expression right here, we're going to say take the 0, add 1 to it, and now this expression evaluates to 1, and we can say gem counter now equals 1. And when it's 1, well, we're going to take the value in gem counter, which is 1, add 1 to it, and now this whole expression over here is 2, and we'll set gem counter equal to 2. So we'll keep doing that, and if gem counter was 117 at some point, Well, we're going to add 1 to it and make this expression over here 117 plus 1, or 118, and store that back into gem counter. So gem counter went from 117 up to 118. Okay? All right, so that's what's going on here. So each time we say, let's keep walking downstairs, moving forward, collecting gems until our gem counter is equal to or greater than 5. Or another way to say it is, as long as our gem counter is less than 5, we want to keep moving forward collecting gems. Where moving forward collecting gems is a function that says just move forward, and if we're on a gem, collect that gem and increment the value of gem counter, or take whatever gem counter was previously, add 1 to it, and reassign that new value that has 1 more than the original one back into the variable gem counter. Okay? All right, let's give this a try by stepping through the code and see what happens here. All right, so the character calls move forward collecting gems, and he's on a gem, so he collects the gem. Then he increments gem counter, so gem counter should be 1 at this point. Then he moves forward. He's on a gem, so he collects it, increments the value of gem counter, moves forward. He's on a gem, so he increments the value of gem counter again, moves forward, collects it, bumps up the value of gem counter again, moves forward. He is on a gem, so he collects that gem and says gem counter is now assigned to whatever gem counter was before, and he bumps that value up to 5. So at the end of this short program here, the value of gem counter should be equal to 5, and this while loop will not run again because gem counter is not less than 5 anymore. It's equal to 5. So this while loop stops, and the character's happy. So this works great. It's another solution to our problem. He went down the stairs collecting gems until he had 5 of them, but this isn't quite what we were going for when we said we would like something to be as generalized as possible here. Something as generalized as possible would work for not only a row of 5 gems, but maybe a row of 28 gems, or a row of just 1 gem, or a row of 1,275 gems, something like that. Any number of gems we would want our program to work. So how can we do that? Well, right now we have as our stopping condition, we're checking if our gem counter is less than 5, we keep going. If it's equal to 5 or greater than 5, we're going to stop. Okay? In this case, since we want to keep walking down a row, collecting gems, we might think of a condition that more better reflects the end of that problem, which is as long as we're maybe not blocked, we want to just keep moving forward collecting gems. Okay, if you notice in this row here, he can keep walking forward collecting gems as long as he wants, but down here at the bottom, he'll be blocked and he'll have to stop. Okay, so let's change that condition to be something like as long as we are not blocked, as long as not is blocked, keep moving forward collecting gems. And let's see what happens if we do that. Okay? Step forward collecting gems. So, is he blocked? No. So he moves forward collecting gems, which is just a move forward. Check if we're on a gem, collect it, bump up our value for gem counter. Again, we're not blocked, so we can move forward, collect a gem, bump up the value for gem counter. We're not blocked, so we call our function move forward collecting gems a 3rd time. We bump up the value of gem counter. Still not blocked for the 4th gem, so we move forward, check if we're on a gem, collect the gem, bump the value of gem counter up. And finally, the last time we check, are we blocked? No, still not. So we move forward, collect the gem, and bump up the value of gem counter. Finally, the last time when he checks, he is blocked. So he stops the while loop and comes down to execute any code that's after the while loop, but there is none. So he's done with the program. Now, that's about as generalized as you can be, because this says for a row of any length, character is just going to keep moving forward collecting gems. Whether it be just the very first time he checks if he's blocked, he may stop, or if the row has 1,000 tiles on it and he's never blocked, he'll still keep walking along collecting gems. Okay? All right, the last final thing to note is nowhere in here is the number 5. The number 5 isn't in here, so you can tell that he's not checking to see if he ever has 5 gems collected. He's just going to keep going until he's blocked. Okay? So there you have it, 3 different ways to do this. The first was just a set of 3 instructions: move forward, collect gem, and assign gem counter to a new value. And we noticed in that one that we can probably put those three commands into a loop to make that code a little more efficient. And then after that, we made it a little more generalized also by creating a function and a while loop, so that if we know how many gems we need to collect, we can just set the character on its way and he'll keep moving along, checking if he's on a gem, collecting it, and right after collecting it, that's the important point here, right after you collect the gem, you want to update your status, or you want to update the character's information by saying, hey, your gem counter just went up by 1 because you just collected a gem. And that's what this important statement says right here. Again, variables, containers that can store values. We can also put expressions and assign the result of expressions, like here, gem counter plus 1. We can store that back into a variable, even if it's the same variable used here, because the process works by, we always evaluate the right-hand side over here. This whole part gets evaluated first, and then that value that results from evaluating this right-hand side gets stored in the left-hand side, the variable. All right. Hope that makes sense, everyone. Good work today. We'll see you next time.